STEM Adventure. Revision Notes. OCR A-Level Physics. Electric fields. Charge is a property we give to particles to explain the characteristics they show. So particles with the same charge repel each other, and unlike charges, attract. The forces that a charge would give to another charge in the area of that charge can be shown with electric field lines. These lines and arrows show the direction a small positive charge would feel if it were placed at that point. Hence, the lines radiate out from a charge and point away from positive and towards negative charges. If the lines are closer together, the electric field is stronger. A uniform electric field will exist between two parallel plates with opposite charges. When charges are brought close together, the patterns combine as shown. There are a number of equations for this topic, and some can be confused as similar symbols are used to represent different quantities. Be sure to be on top of what each equation represents. Firstly, we can define the strength of an electric field E by the force per unit charge at that point. For a uniform field between parallel charged plates, the electric field strength is given by the potential difference divided by the separation between the plates. The force between two charges can be calculated in terms of the two charges and the separation between them. Note that the force reduces by the square of the separation between them. Couple the electric field strength equation and the force between two charges equation, we derive another equation for electric field strength in terms of the distance from a charge and the magnitude of the charge. Capacitors rely on the electric field between the plates to function. We can express the capacitance in terms of the size and separation of the plates and the permittivity of the material between them. Permittivity is a measure of a material's resistance to producing an electric field. An isolated charged sphere can also be thought of as a capacitor, with a capacitance which is proportional to the sphere's radius. Electric fields and gravitational fields share some properties, for example, a field strength that is proportional to 1 over r squared. However, some properties are different, like the fact that gravity is only attractive. When a charged particle moves through an electric field, it will be deflected. Its motion is similar to that of projectile motion of a mass through a gravitational field. Finally, for this topic, we will define two important concepts. The first is the electric potential energy. This is defined as the work done in moving a positive charge from infinity to that point. As the force on the positive charge will increase as it moves from infinity, we need to consider the work done as the area under the force distance graph. The electric potential energy is therefore defined as proportional to the product of the two charges over the separation. We can then introduce our final term, which is the electric potential. This is the work done in moving a positive charge from infinity to a point per unit charge. This resource and many more can be found on our website at stemadventure.space